The Vorticella telotroch. Vorticella is a solitary peritrich ciliate with an inverted bell-shaped body and a myonematous contractile stalk. Vorticellae are classified as sessile because they are generally attached via a stalk to a fixed location in the environment. Vorticella is placed in the subclass Peritrichia, as described by Stein in 1859. Vorticella is placed in the order Sessilida, as described by Kahl in 1933. And it resides in the family Vorticellidae. A sessile individual Vorticella, attached to a fixed position in its environment, can undergo morphologic metamorphosis into a potentially free-swimming motile organism and disconnect itself from its stalk and migrate to a new location, possibly a more hospitable environment. The free-swimming migratory stage is known as a telotroch. This diagram, scanned from John's text, shows sequential morphogenesis of Vorticella into a telotroch. This process will be illustrated in the photomicrographs and videos to follow. However, it should be noted that they show telotroch formation following upon binary fission. The illustrated steps include binary fission, elongation of the forming telotroch, development of the basal ciliary trochal ring, detachment of the free-swimming larva, and eventual resettlement of the larva as a new solitary organism. The Vorticella telotroch. This video movie of the formation of the Vorticella telotroch shows late daughter cell formation from a mature sessile organism which has already duplicated its cell membranes, cytoplasm, and organelle content and has begun to divide. In this program, the telotroch does not develop from a small bud at the base of the parent cell, but rather from an equal-sized daughter cell formed by binary fission of the parent cell. In the movie, the visible process of division begins with the development of a crease in the anterior midline of the parent cell. This crease gradually extends posteriorly to form a cleavage membrane which progressively separates the two cell products, the parent cell on the left and the daughter cell on the observer's right. Note that during this period, the two cells appear to have open communication across the incomplete membrane. It should be noted that the parent cell is identified by its direct attachment to the apex of its stalk via its collar, whereas the daughter cell is attached laterally as an extension of the side of the parent's collar. Nonetheless, the parent cell and the daughter cell are otherwise approximately the same in size and shape. The outcome is the formation of side-by-side cells connected basally to a common stalk. The head of the stalk can be seen through the base of the parent cell. As cleavage and separation proceed, the daughter cell has shifted its basal location sidewards, and only the parent cell retains direct basal connection to the head of the stalk. The daughter cell will thus further establish its separation from the parent cell in anticipation of its development into a telotroch. At first, the parent cell and the daughter cell maintain a remarkable degree of morphologic symmetry in their maturation. Note here the distinct equality of the nuclei of the two product cells. These two side-by-side cells now lengthen, taking on the bell-like outline of the typical mature Vorticella cell body. Note the continued appearance of a remarkable degree of symmetry. The anterior oral region differentiates, developing a circumoral lip surrounding new ciliary membranes. However, there is a new developing differentiating feature in the daughter cell. It is a wreath or ring of coarse cilia near its base. Now the daughter cell begins to independently contract, and towards the end of its contraction, we see that it has withdrawn and inverted its oral cilial structures. The organism is rounded. The mouth appears almost sealed, and the wreath of basal cilia is coarse and hyperactive. The daughter cell contracts into a spherical shape, and then it expands into the semi-rectangular shape of the almost mature telotroch. Now there is further extension of the length of the telotroch, and when the Vorticella swings away and returns, it has released the telotroch. Note the small piece of what appears to be torn cytoplasm at the site at which the telotroch had been attached. Here is the video in its entirety, sped up 8-fold and approximately 2½ minutes in length. The original video runs somewhat over 20 minutes. Additional videos of the free-swimming telotroch will be the subject of another program.